Hello everyone, welcome back to my channel. So in today's class we will going to study about the divisibility rules, square roots and also shorts and indices from unit 1. So let's start the video. So we will learn the divisibility rules for 2, 3, 4, 5, 6, 8, 9, 10 and for 11. So the first divisibility rule is for 2. So it is given that a number is divisible by 2 if the last digit is even. So the even numbers are nothing but 2, 4, 6, 8, 10, 12 and so on. So these are the even numbers. So whenever a number is given to you, the last digit means, suppose consider an example called 5, 2, 8, 1, 3 and 4. So this is our unit place, or it is also called ones place. So in that place, if you will get a number called 0, 2, 4, 6, 8, so in that case it is said to be this number is divisible by 2. So here the example is given 454. If you see here 4 in the units place, 4 is present. So this number is divisible by 2. And the second example it is given 455. In the ones digit it is given 5 where it is not divisible by 2. Similarly, we will go for the test for 3. That is divisibility test for 3. It is said that a number is divisible by 3 if the sum of the digit is divisible by 3. Like here it is given the example called 459. So 459. If you see here, on adding these numbers, you will get the value called 18, where this number is present in the table 3. So it is divisible by 3. Let's take one more example like 8, 5, 3. So when I add these numbers 8 plus 5 plus 3. So on adding you will get the value 16. So which is not present in the 3 table. So this is not a divisible by 3. So this number is not divisible by 3. Now divisibility by 4. A number is divisible by 4 if the number formed by the last two digits is divisible by 4. See here, when we were studying about the divisibility by 2, we used to see the ones digit. So ones, tens, 100. We used to see when we have a rule for 2, used to check for ones place. And similarly for divisibility test for 4, we have to check for ones as well as tens place if it is multiplied or that number is gets divided by 4. Like example, it is given 324. 324. So in the ones and tens place, you have to check for these two numbers. If this number gets divided by 4, then the 324 will also gets divisible by 4. Then divisible by 5. Divisible by 5, it is given a number is divisible by 5 if the last digit is either 0 or 5. That means in the ones place, either you should have 0 value or 5 value. Like example, it's already given 555. So in the ones place 5 is present, so it is a divisible by 5. If suppose it is given 550, so this number is also divisible by 5 since in the ones place 0 is present. Now divisible by 6. If you will check for divisibility test for 6, it is said that a number is divisible by 5 if it is divisible by both 2 and 3. That means to confirm that a number is divisible by 6, you have to check for 2 as well as 3. If these two conditions get satisfied, then the number is divisible by 6. Like example, it is given 528 is a number. So first we will check whether it is getting divisible by 2 or not. So yes, because in the ones place 8 is present, so it is getting divisible by 2. And now for divisibility test for 3 is we have to do the sum for the given number. That means 5 plus 2 plus 8, which is 15. So this is a multiple of 3. So this is also a divisible, a number 528 is a divisible of 3. So these two conditions got succeeded. So this number 528 is divisible by 6. Now we will go for the divisible test for 8. So it is given that a number is divisible by 8 if the number formed by the last 3 digits is divisible by 8. That means, as we have saw, for the divisibility by 2 we used to check the ones place, and that number should be in the should be in the form of even number. And for the divisibility test for 4, we used to check last 2 digits, that is ones as well as tens place, and that number should be multiple of, that means that number should be divided by 2. And similarly for the 8, we have to check the ones, tens as well as 100 place, whether it is getting divisible by 8 or not. Here the example is given 8168. So 168 is divisible of 8. So that's what the number 8168 is divisible by 8. Now divisible by 9. So for this, a number is divisible by 9 if the sum of the digit is divisible by 9. That means same as 3. That means where we used to do the divisible test for 3, in that case the number, after adding the given number, we should get the sum value which is divisible by 3. So in this test, we have to get the sum of the given value that should be a divisible number by 9. Like example, it is given 981. If you check this one, on adding these values, 8, 9 plus 8 plus 1, which is equals to 18. So 18 is divisible by 9. So 981 is also a divisible number of 9. So this is what the test for 9. And divisibility by 10. If you check for the divisibility test for 10, that should be, the last number should be 0. So you have to check in the ones place. In the ones place, you should have the number 0, then only a number is divisible by 10. The example here, it is given 100 is divisible by 10. That means in the ones place we have 0, that's what it is divisible by 10. Now we will see for the divisibility test for 11. So for the 11, the rule is to find out if a number is divisible by 11, find the sum of odd numbered digit and the sum of the even numbered digit. Now subtract the lower number obtained from the bigger number obtained. If the number we get is 0 or divisible by 11, the original number is also divisible by 11. That means here the example is given. Consider an example like 1 3 3 1. So just number it as odd number, even numbered, odd numbered, even numbered. You're not supposed to point whether it is an even number or odd number, but we are pointing out the place for this number. That means 1 is an odd numbered place, 3 is even numbered place, again 3 is in odd numbered place, and 1 is in even numbered place. So the even number places should be added and we get the value as 4. And similarly, the odd numbered places, on adding we will get the value 4. On subtracting the answers from greater number to lower number, when we get the value as 0, then this number is divisible by 11. Otherwise, if you will not get the value as 0, the particular given number is not divisible by 11. As here it is given an example 121. So let's start with odd place, even placed, odd placed. So let me add these odd placed numbers. On adding, you will get the value 2, and by subtracting the even valued value, you will get 0. So 121 is a number divisible by 11. So now we will solve some of the questions which is related to the divisibility rule. So the question is given here that 8550, what number should we replace here so that this number will be divisible by 3. So we know the test that number which is given to us, we have to do the addition and that number should be divisible by 3. So let's add these numbers, that is 8 plus 5 plus 5 plus 0 plus 1. So let's add these numbers. You will get 19. So which is not divisible by 3. Let's move forward. So if you go, 21 is divisible by 3. So if we will add plus 2 for this number, we get 21 which is divisible by 3. So the value here we get is 2. Now the next one, find the least value of star for which the number. So here the number is given 3, 1, 3, star and 1. So this number should be divisible by 11. What number should we replace here? So in this case, this is our odd place and this will be our even place. So this is our odd place. Again, this is our even place. So overall, if you will see, when we add the odd places, you will get the value 4. And similarly, if you will add the even places 1 plus, so consider here we have a 0 value which is equals to 1. So now let's subtract the greater number with the smaller number and we get the value 3. So here we have to replace 3 so that this number will be divisible by 7. Now let's go for the next question. It is given, is 7248 is divisible by 4. For the divisibility test, we have to check for 4. The last 2 digits should be divisible by 4. So yes, it is divisible by 4. And for the second question, it is given, the number should be divisible by 2. So we have to check the ones place whether it is divisible by 2 or not. Since here we have to get the even number. So here we have an even number. So here also the number will be divisible by 2. Now it is given by 8. So if you will see last 3 digits, we have to check for the divisibility test of 8. So 248, if you divide this number by 8, so here if you will get, what we have is 3 times of 8 will be 24 and then 8 ones are 8. So if you see here, we get the value 31 which is divisible by 8. So this is also we have the number, that means 7248 will be divisible by 9. Now we have the next question, that is, a number is divisible by 4 and 12. Let us consider a number A. This number is divisible by 4 as well as 12. Is it necessary that it will be divisible by 48? So if you multiply 12 into 4, you will get 48. Give an example in support of your answer. So if you will see 48 which is equals to 4 into 12. So this number is given, but if you will see, these two numbers are not co-prime because we have a common numbers, that 4 has a factors like 1, 2 and 4, and similarly 12 has the factors 1, 2, 3 and 4. If you will see, we have a common factor, so which is not a cofactor. Therefore it is not necessary that the number will be divisible by 48. So there is no rule to that this 48 should be divisible by 48. If you will see an example 72, so for 72, if you will see, it is divisible by 2 since the ones place has a even number, and also divisible by 4. And if you will divide this number by 4, you will get the value as 0. This is also divisible by 4, but it is not a divisible of what we have is 48. So this is not divisible. That's the answer. Now, the next question, it is given without actual division, find if the number is given is divisible by 4 and by 8. So for divisible by 4, we have to check the last two digits, that is 32 is divisible by 4. Yes. And then for 8, the divisibility rule is 932. If you will see this one, this number is not divisible by 8. So that's what we have in this part. So now we have a topic, square roots. How should we find the square roots? By a long division method. So here you will have the steps, that is step 1, 2, 3, 4 and 5. In step 1, it is given that group the digit in pairs starting with the digit in the unit place. So let me explain this topic by the example so that you can understand betterly. So the question is given, find out square root of 16,384. So for this, first we have to write like this. Make an horizontal and vertical line and then write the number given. After that, pair the numbers. See here, we have to do the pairings from starting from right to left. Okay, these two are one kind of pair and these are the pair, and one is the number which doesn't have any pair. So let's make that number as single. Now let's check. As we know the square root value. So 1 square value is 1, and then 2 square is 4, then 3 square is 9. In this step, we only consider the square values. If you will see here, we have a value 1. So 1 square is 1. So which is 0. Now in the next step, we will consider, because it is a pair, we will take 63. So now add these two values. On adding these two values, you will get the value 2. Then in the next step, the number which you will replace, that means the number what you will add here, you have to add the same number here. So if you will see, and that should be divisible by 20, that means the number should be divided by 63. So if you see here, if I multiply 2 here, and I should replace 2 here also, so 22 times of 2 is equals to 44. Suppose if I replace 3 here, I have to replace here also 3. So 23 times of 3 is equals to 69. So which is a greater number. That's what I have taken. 22 times of 2 is multiple. Then the answer is 44. Now on subtracting, we get the value as 19. Okay, on subtracting I got the value 19. Then the next pair, which is 84. Now again add these two numbers, that is 22 along with this number. So 22 plus 2. Okay, so 22 plus 2 will be, the answer is 24. Now substitute the number here. The same number has to be substituted here. Okay, the number which we replace here, we have to put the same value here. So 24 times, and if I add 8, because if you will see in the ones place the 4 is present, so if I either I can multiply 2, because the ones place you will get the value as 2, or I should multiply 8 because 8 is a 64. So in the ones place I have 4. So that's what I have taken 8. Here also I have taken 8. So 248 into 8, the answer will be 1984. So the answer is this one, that is 128 is the square root of the given value. So root of 16384 is equals to 128. Now let's go for the second question. It is given to find the square root of 66049, and we will make a horizontal as well as a vertical line, and then we will pair up the numbers, and we have a 6 here. So if you see, by taking a square value of 1 square, you will get only 1. So 2 square, the value will be 4. 3 square, the value will be 9. So I can consider 2 square. So 2 2s are 4, and I got the value here on subtracting 2, and then the pairing value, that is 60. Now I will add these two numbers. 2 plus 2 is 4. So let me substitute, that means let me replace a number that should be multiplied. If you see here in the ones place it is 0. Either I should add 0 or 5. See here, if I add 0 and here also 0, then I get only 0 only. So that's what, if I add 5 here and here also if I multiply 5, that means divisibility test, then I get the value as 22. And if you required, you can check for 46 into 6. So here you will get 6 4s are 24, 24 27. So this is excluding value, so that's what I have taken 5 into 5. So this will be 2 to 5, and the remainder will be, on subtracting this value you will get the remainder as 35. But here we have one more pair. Now let's take that pair and add 45 plus 5, you will get the value 50. Now replace a number, and here also we have to add a number that should be multiplied. So here we have a 49. If I take 7 and here also 7, if you see 507 into 5, so which is 49, and 5 7s are 35. So here 3549, which is 0. Okay, so this is a topic given for to find the root values. Now we have a topic called shorts and indices. So what is the index? So the index plural form is known as indices, which is nothing but the power, or which is also the other name we have is exponent. Like example, if you will see, a to the power of 5 is given, and this 5 is known as indices, or which is also called power or exponent. Okay, so now if I take the example 2 to the power of 7, so here 7 is the power or exponent which we have to call. Now short. A short is an irrational number that can be expressed with roots. So whatever a rational number is given, so see here the example is given, let a be a rational number and n be a positive integer such that a to the power 1 by n. So this 1 by n can be written as root of a. Here we have to write n, then a is called a short of n. So here a is considered as short of n. Also we have some laws for the indices, that is a to the power of m into a to the power of n is equals to a to the power m plus n. Like example 3 to the power of 2 into 3 to the power of 3, then it can be written as 3 to the power 2 plus 3, that means 3 to the power of 5. So on multiplying you will get the answer. The next indices, it is given a to the power of n to the power n, then which is equals to a to the power mn, that means 3 to the power of 2 whole power 3, so which is equals to 3 to the power 2 into 3 is equals to 3 to the power of 6. Now the next question, it is given ab to the power of n, which is equals to a to the power of n, b to the power of n. Like if you will see 3 into 2 to the power of 3, so 3 to the power of 2 into 2 to the power of, sorry, here we have to write 3, or 2 to the power of 3. And there is one more formula is there, which is a to the power of m by a to the power of n is equals to a to the power m minus n. So here consider 3 to the power of 5 by 3 to the power of 6. Not 6, consider value like 4. Okay, like 4. Then 3 to the power 5 minus 4, which is equals to 3 to the power of 1. Similarly, a to the power of 0 means 3 to the power of 0, the value will be 1, or 5 to the power of 0, the value will be 1. Then a by b whole n, which is equals to a to the power of n by b to the power of n. So 3 by 2 to the whole power of 5, which is equals to 3 to the power of 5 by 2 to the power of 5. Then here it is given a to the power minus n is equals to 1 by a to the power of n. Like 5 to the power of minus 2 will be given to you. Then that can be written as 1 by 5 to the power of square root 2. Then there are laws for shirts also. So as we know, when the root number changes, that means if you have a root number, then I can write this one as 1 by 2, right? Similarly, here it is given root and then it is given here n. That means this can be written as a to the power 1 by n. And then, so here it is given root a and here it is given n, then again the root m. So these two numbers can be multiplied, and then it is given a by b whole root over n, then this will be equal to the power 1 by n. So there are some formulas here, let's see, and now we will do some examples based on this topic. So here the question is given, the divide 12 by 3 root 2. Now we will use the rationalization method. So root 2 by root 2. To cancel the root 2 value, we just multiply root 2 in the numerator as well as in the denominator. 12 root 2 by 3. So root 2 into root 2 value. Okay, so if you see here, the root 2 value will be same, remains 2 only. So for that, into 2. So here we have a value 2 ones are 2 6 times, then 3 ones are 3 2 times. So 2 root 2 is our answer. Now we have simplify 125 to the power 1. Okay, wait. Simplify 125 to the power minus 2 by 3. Okay, so for that, let me express this as a power value, like take the LCM. If you will see here, 5 2s are 10 and 5 5s are 25. Again, 5 times of 5 we get 25 and 5 ones are 5. So this 125 can be expressed as 5 to the power of 3, right? So for this, again we have a power value minus 1, not 1, minus 2 by 3. So this can be written as 5 to the power 3 into minus 2 by 3. So here the 3 value will get cancelled out and the remaining will be 5 to the power minus 2, which is also 1 by 5 by 2 by using the law of indices. Okay, for that we get the value 1 by 2 to 5 to the power of square means 25. So this will be our answer. And then the next question, it is given 15 to the power of 4 into 15 to the power of x is equals to 15 to the power of 6. So for this, we can do this one in two ways. So by taking powers, if the bases are same, we can add the powers. So 4 plus x is equals to 6, and simply x is equals to 6 minus 4, x is equals to 2. In this method also we can solve for the value x, and there is one more method, 15 to the power of 4 into 15 to the power of x is equals to 15 to the power of 6 is given the question. So let's shift this one to the other side. Here it is in the multiple form. When this shift to the right hand side, then it gets divided. So 15 to the power of x is equals to 15 to the power of 6 by 15 to the power of 4. So 15 to the power of x. By following the law, 15 to the power 6 minus 4. Then this will be written as 15 to the power of x is equals to 15 to the power of 2. So x value is equals to 2. Okay. Now the last one. If 2 to the power of a is equals to 64, find the value of 2 to the power a minus 3. So first we will find the value of a. So let's take the LCM for 64 to convert this into 2 to the power of something, like 2 to the power of 3, something like that. Okay, so now take the LCM. 2 3s are 6, 2 2s are 4, then 2 1s are 2, 2 6 are 12, 2 times of 8 is 16, 2 times of 4 is 8, 2 times of 2 will be 4, and 2 times of 1 is 2. So see here how many times the 2 is gets repeated out. So 1 2 3 4 5 6 times 2 is repeated out. So this 64 can be written as 2 to the power of 6. So by the question, 2 to the power of a is equals to 2 to the power of 6. So here we got the a value as 6. So that's what I can write, a is equals to 6. Now by using this a value, we have to find the value of 2 to the power a minus 3. So 2 to the power a value is 6 minus 3, which is equals to 2 to the power of 3. So on solving, we will get the value 8. So this is what we have the examples related to this topic. So this is the complete unit 1 has covered in this video. So that's it for today. Thank you.